Now let's look at the third question. The third question actually very similar to the part B question, right? Because the third question just want to construct a 98% confidence interval of mu. So here we still have the x bar equal 18, and from part B we notice their sample standard deviation equal to 2.61, right? However, now the confidence level changes to 98%, which means we need to use 1 subtract alpha here should equal 0.98, okay? So from this part, we notice alpha will equal 0.02, right? Therefore, alpha over 2 will equal 0.01, okay? Therefore, we still have the degrees of the freedom. So the degrees of the freedom still equal n subtract 1. So 6 subtract 1 equal 5. But now we need to find out the t-value at 0.01 if the degrees of the freedom equal 5, right? So we still need to go back to our t-distribution table, okay? And then find out this t-value. So go back to this t-distribution table. You might find out we still have the degrees of freedom equal 5. However, now the t-value should at this level, okay, 0.01. Therefore, we have the t-value equal 3.365, okay? So we just need to write it down. The t-value here is equal to 3.365, okay? So now we have all the informations to compute the interval estimate of population mean, because here we have the t-value, right? Finally, find out the t-value. And then we also have the sample size, have the standard deviation of the sample mean, and then the and the population mean 18. So finally, we just need to put all those numbers together into this formula. Then we can get the interval estimate of mu, okay? So here we can finally get 98% confidence interval estimate of mu will equal 18 add or subtract 3.365 times 2.61 divide the positive square root of sample size. Okay, so sample size is 6. So finally, we can find out this interval lies between 14.41 to 21.59. Okay, so this is the answers for part C. And if you go back to check part B's answer, you notice from part B, okay, I'll just write it down. From part B, we have the 80% confidence interval of mu actually equal 16.43 to 19.57, right? So compare with these two interval level, you might notice as the confidence interval increase, okay? As the confidence interval increase, then we can notice we will get a wider confidence interval estimate of mu, okay? So here I will just write it down. Maybe it's a little bit space for me to write it, but I can still write down as confidence level increases, okay? So from 80% to 98%. The interval estimate gets wider. Okay, so that will be the conclusion. Okay, so this will be the conclusion for part D. Why 80% and 98% confidence interval are different? Because as confidence levels increases, now the intervals will get wider. Okay, so that will be the practice question for chapter 8 about how to estimate the interval estimate of population mean if population standard deviation sigma is unknown.